Ask an AI something about your own team's documents, your PTO policy, last week's product update, and watch it either guess or admit it has no idea. That's because a language model only knows what it saw during training, frozen at a cutoff date, with no access to your private files, and nothing that happened after that cutoff. You could retrain it on your data, but that's slow and expensive, and it risks the model forgetting things it used to know. RAG never touches the model's weights at all. It only changes what the model sees the moment you ask. Retrieval-augmented generation, RAG, fixes this differently. Instead of retraining, you give the model an open-book test. Before it answers, it looks something up. 3 steps every time. Retrieve the most relevant information for the question, augment the prompt with it, then generate an answer grounded in what it just read, not what it memorized. That's the difference between a confident guess and a sourced, checkable answer. Support bots that stay current without retraining every week. Compliance tools that cite the exact clause they relied on. Research assistants that work across more documents than one person could ever read. So let's build one from scratch. Say you want an assistant that can answer employee questions from your team's internal wiki, PTO policy, expense reports, onboarding steps, all of it. Step 1, collect your documents. Wiki pages, PDF, old support tickets, anything you want this assistant to actually know about. Step 2, chunk them. A whole 10-page wiki page is too big and unfocused to search well, so you split it into smaller pieces, a few hundred words each, with a little overlap, so a single idea never gets cut cleanly in half. Step 3, embed each chunk. An embedding model reads it and outputs a vector, a long list of numbers that captures its meaning, so 2 chunks about similar topics land close together in that number space. Step 4, store every one of those vectors in a vector database, purpose-built to search by meaning instead of keywords, fast, across thousands of chunks. Now say an employee actually asks, "How do I request PTO?" Step 5, you run that question through the exact same embedding model, turning it into a vector 2. Step 6, the database compares that question vector against every chunk vector and returns the handful closest in meaning. In this case, your actual PTO policy page. That's your retrieved context. Step 7, assemble a new prompt, your system instructions, that retrieved PTO passage, and the original question, all bundled together. That's the augmented half of retrieval-augmented generation. Step 8, send that whole package to the language model. It writes its answer using the actual policy text it just read, not a guess from memory. Step 9, return the source passage right alongside the answer, so the employee or you can click through and check exactly where it came from. All of this embedding the question, searching the database, generating the answer typically happens in under a second, end to end. One warning, this only works if retrieval finds the right chunk in the first place. Feed the model the wrong passage, and no amount of clever prompting saves the answer. Garbage in, garbage out. That's the minimum viable pipeline. Real systems tune it further, smarter chunking, hybrid keyword plus vector search, re-ranking retrieved results, even caching frequent questions. But every one of those improves these same 9 steps. It doesn't replace them. Documents chunked, embedded, stored. A question embedded, matched, retrieved, augmented into a prompt, generated into an answer with its sources attached. 9 steps, 1 loop. Retrieve, augment, generate. That's RAG, end to end. Build it once, and you'll recognize it running under almost every AI tool that actually knows what it's talking about.